Determine whether the integral is convergent or divergent. The integral from 0 to infinity arctan of x over the 2 plus e to the x. So the problem is at infinity, and what we need to do is find a function that we can either say is bigger than this function or less than this function. Arctan of x is always in between minus pi over 2 and pi over 2. As x goes off to minus infinity, it goes to minus pi over 2. As x goes off to infinity, it goes to pi over 2. With the 2 in the denominator, we could get rid of it. As x gets large, it becomes insignificant. By getting rid of it, we make the whole fraction larger. We're taking away something from the denominator, divided by something smaller now. So the whole fraction is larger. And so what we're going to do is take our function and replace the arctan of x with pi over 2 and drop off the 2 from the denominator. And in turn, what we have obtained is a larger function. This function here is larger than our given function. Remember from the comparison theorem, if we have a function that's larger than the given function, what we want to do is call that f of x, and if that function has an integral that is convergent, then our function has no choice but to also be an integral. The area under our curve is also convergent. We have the f of x function. We have the g of x function. Oops, sorry. The g of x function. If we can show that the area under f of x is convergent to some number, we don't have to know the number, as we go off to infinity, then the area under g of x will have to also be convergent. So let's deal with that. The integral from 0 to infinity, pull the pi over 2 out. And then have e to the negative x dx. So that's negative e to the negative x. With the pi over 2 out there. And we have to let the upper limit go to infinity. Let's write it as the limit as b goes to infinity, pi over 2e to the x from 0 to b. And what's going to happen with that is that we're going to get, as b goes off to infinity, that this part goes off to 0. Denominator is getting larger, numerator staying constant, so it's going to go off to 0, so it's convergent. Great. So then, by the comparison theorem, we also have the integral from 0 to infinity of the g of x function the given function is also convergent.